Hello, today we're going to review the 45, 45, 90 triangle real fast, and we're going to make this equal to 1 right here. We're going to let that equal 1 like it's our unit circle with a radius being equal to 1, even though we won't technically talk about this as a unit circle because this would be in the second quadrant, but you get the idea. We're going to let the radius equal 1, and I want to show you a pattern that happens here. If you're going to figure out what A and B is, we know that A equals B on a 45, 45, 90 triangle. And if we use the Pythagorean theorem, instead of having A squared plus B squared, we'll do it A squared plus A squared equals 1 squared, which would be C squared. And this is going to wind up being 2A squared equals 1, dividing by 2. A squared would equal 1/2. So this, you would have to square root both sides. And so A would equal the square root of 1 over the square root of 2, which we would have to multiply the top and bottom by the square root of 2 because we don't want to have radicals in the denominator. And of course the square root of 1 would just be 1. So this is 1 times radical 2, which is radical 2. Radical 2 times radical 2 would be 2. So A and B would both be equal to the square root of 2 over 2, like this. And the real question is, how do you use this rule when when these things are all different? And let me show you a couple examples of how this all works out. There's a couple ways you can look at it. We know that A equals B, and that would equal C times this. Okay, C would be 1. So in this case, this right here would be 1 times radical 2 over 2. And if you solve this, you would see that this would be something that's really important to memorize here. Because this relationship happens for all 45, 45, 90 triangles. And let me just let me show you a different example here of that. So I got one preset up here. I don't know why that keeps doing that. Sometimes it does, sometimes it doesn't. But here we have one set up to where we know one of the littler sides. And let's look at it. So we know our formula is, and again, okay, A equals B equals C times radical 2 over 2. We know that this is true. So we know that this equals 7 because they're both the same size. These opposite sides are equal because the angles are equal. And then we know that C would have to equal, since B is 7, we can just go right in here and apply this. That would be 7 for B equals, we don't know, times radical 2 over 2. And to solve this, I would of course divide both sides by radical 2 over 2, which would be like multiplying by this reciprocal. So it would be 7 over 1 times 2 over radical 2. Now, here's what happens. 14 over radical 2. And of course, we've got to clean this up. So we multiply the top and bottom by radical 2. And this would become 14 radical 2 over 2, which would cancel to 7 and 1. So this would become 7 radical 2. This is correct. And you could also check this with the Pythagorean theorem if you want, which I'm not going to, but I invite you to do A squared plus B squared, get C squared, and you'll see that it does reduce to that. But you can also think of the 45, 45, 90. I'll just draw a freehand version of that. 45, 45, and this is of course 90, where we have A, B, and C. If you look at how this works out here, this is 7 radical 2. I just inserted this answer here. And if this is 7 and this is 7, this is just going to be 7 times the square root of 2. So if I make this 5, well, this will be 5, and this will be 5 radical 2. If I do a different one, if I get rid of that and that, and I make this some other random number, like like 9. This would be 9, and this would be 9 radical 2. This totally works. If I outline this in black, maybe you can see it better. 7, 7, 7. And this would be 9, 9, 9. And you just add the radical 2 on the hypotenuse. But what happens when you're given the hypotenuse and not a short side? So let's look at that one. And let's let this thing pop out like it's not supposed to. This time we'll draw a nice one. Make it like that. Nice little right triangle there. And we're assuming this is 45 and 45. And this time we'll let C equal some value like 10. All right? And we're going to find out what A and B equals. Can you do this? Well, if we go back to the formula, A equals B equals C times radical 2 over 2, and there are other ways to write this, but this is how I'm going to present it, then we can find out what the short sides are, because if we say, okay, if I want to find out what B is, we go B equals C times the square root of 2 over 2, and if we substitute 10 in for C, it would be B equals 10 times the square root of 2 over 2, which this would, of course, be 10 over 1, and that would cancel like so. We'd have 1 and 5. And so B would equal 5 radical 2 here. And, of course, this would become 5 radical 2. And if we wanted to check this, now remember, these aren't whole numbers this time. If you look at the ones we did previously, these were whole numbers, and this had the radical 2 on it. If we wanted to check this with the Pythagorean theorem, it would just be a squared plus b squared, just to make sure all is right in the world, equals 10 squared. And of course, 5 times radical 2 over here, 5 radical 2 times itself would be 25, so that's 5 times 5 times radical 2 times radical 2, which would be 2, and that equals 50. So this is 50 plus 50 equals 10 times 10, which is 100. So 100 does equal 100, therefore that is correct. And you can always check yourself like that. When you start doubting yourself as the weeks come, that way you'll know you are correct. I hope you enjoyed this. Have a good one.